linear increase as we move in this direction. These variables that have the same, a vector in that direction are increasing, right? The problem is sometimes you might have information on that plot that is nonlinear. Right? We might have some variable that goes small and then big and then small again, right? And that can't be captured with a linear relationship. The correlation would be 0 for that, right? Going big to small to big or vice versa is we're not gonna find that by trying to find a vector describing those values relative to the positions, right? So as a consequence, what you often might want to do, if you want to be a little bit more thorough, is do a bubble plot. A bubble plot is going to actually project, you choose whatever value that you're interested in, right? So let's choose a value, I don't know, annual average, something relative humidity, I forget, percentage relative humidity, or this one here, population per square mile, right? That doesn't appear to be correlated with any particular direction very strongly, right? But maybe it's because we've still got a relationship there, it's just modal, it's going small to big to small or something like that, right? So instead you would do a bubble plot and you would actually do the same plot, right? So it's a PC plot, but the size of the bubbles is going to be determined by the variable that you're interested in, right? And then you can see, hey look, in general, for these things with big arrows like this, you should see you would see small bubbles and then big bubbles as we get further across, right? Because we know that the average January temperature is strongly correlated. We know there's a strong correlation here. But for these ones with relatively small arrows, there might still be information in that plot, it's just not linear. And that's when the bubble plot comes in. So the bubble plot we were doing with respect to height and weight, right? So there was a data set, here we go, class data set in the SassHelp library, and there was height and weight, I don't know, 19 different people, right? And we plot their height and weight, basically, and we could plot the bubble by their age as well, and not surprisingly, on average, as we got taller and heavier, they tended to be the older people as well, the older kids. And we have this poor kid down here who's just a baby, but is also very small. Right? So that's not surprising. Everything is nice and linear there, right? PC1 and PC2. This was with respect to the value density, right? So we would argue, if we would look back at density this is the pollution data set, was it? Yeah, the pollution data set. Do I still have that? Where's the density vector here? Can you guys see it? You are my density. No? I don't know. See if we can work it out. I don't really see it there, so it's hard to say. Density, population per square mile in urbanized areas. Here we go. This one here. See, that's the vector for density. Right? And we can see that there's no strong, it's a very small arrow, right? So there's no strong linear relationship in any particular direction here. So we would expect, maybe just a random scattering of different sized bubbles on that plot. But there could be potentially going from small to big to small. And is that what's happening? I don't know, we've got quite a few small bubbles here, some big bubbles here. I don't know, maybe there's some evidence of small to big to small, but it's hard to say really, isn't it? It's not really clear. But that's what you would use. That's one way of doing it. You could use color instead of the size of the bubbles, where you have a color ramp and you might have blue to red to blue, like that. To some people that's easier to read, using color as a method for looking for nonlinearity. Right? So these vector plots, the biplots are great, but they are assuming that there is a linear relationship, right? So if you're just going to rely on those vector plots, you are relying on looking for linear relationships between the data. If you're worried there might be a little bit more to it than that, then do a bubble plot as well for those variables. Right? So that's the reason why we do the bubble plots, to check for nonlinearity. Okay, that was all. Okay.